Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the HPC number C14 code card. And if you're looking at this code card, you probably know all of the information that is contained on a HPC code card, and that you just need the card. However, if you're unsure, we can take a quick tour of the card. HPC will tell you the jaw from the machine to use. They will tell you the cutter that you need to use. They're going to give you your depth and spacing chart over here for your depths and your spaces. So what's important is space 1 is your stop to first cut. So this card is indicated as the shoulder stop to the first cut, and that's 0.25 inch. You'll then notice, so when cutting a key by code, you need 3 pieces of information. You need to know the shoulder to the first cut, to the stop, or to the first cut, whatever that is. It could be a tip stop, it could be a shoulder stop, it could be a tip stop would be like a Ford ignition key. A shoulder stop would be this key, you know, a regular key, non-interchangeable core, non-automotive. You could have the stop underneath the key blank, which you could certainly see on some types of keys that would feature a stop underneath the key, you know, near where the root of the key is cut back. It could be stopping there as well. I can't think of a key that takes that sort of stop, but nonetheless. So they're telling us the first space, which is from the shoulder stop to the first cut. Then 0.156, that is the center to center of each successive cut. So you'll make your first cut 0.25 from the stop. Then the third piece of information is the depth. Then you know your center-to-center spacings, which is 0.156, and you can verify that by taking 0.25 and adding 0.156 to each successive number down my finger. Okay. Now you'll note that the depth over here, a 1 depth, is a number that's larger than a 7 depth. So how is it that a 7, which is a deeper cut, is a smaller number? Well, that's measured from the root of the key to the bottom of the cut. So you take the overall height from the top of the uncut blade to the bottom of the root, measure the cut, that will give you the pin height, but that depth cut is the root, the underside of the key blank, to the bottom of your cut. So that's why that's like that. It gives you your depth increment. So the distance between a 1 and a 2 is 0.014, and you can test that by subtracting those two numbers. Again, gives you your space increment. Important code information will be listed here if you have a reference, code book references. Codes, if available, are listed tip to bow on head of key. So if there's a direct digit, they're saying to you that it's tip to bow, so be mindful of how that code is being shown. This will also tell you the system that's being used, the key blanks that you can use, the direct series, the DSD number. I always forget what that stands for. Let's take a look. Direct series digit, maybe? The DSD list is depth and space data, DSD. Depth and space data. There is a listing on the manufacturer's website of the depth and space data, and if you went in that page to entry number 18, you're basically going to get all of this information here. Then you have your MACS, your MACS, which is your maximum adjacent cut specification, which is an 8 on this system, which means that no two consecutive cuts can be greater than 8. Otherwise, the depth of one cut will obliterate its adjacent very shallow cut. So that's your MACS, M-A-C-S. Then progression step 2, this would be founded on a 2-step progression where you are literally building your bitting numbers in a 2-step progression. So if you were dealing with cuts, there is no 0 in this system, so if you were dealing with odd numbers, 1, 3, 5, 7, you're always going to go 1, 3, 5, 7, meaning you wouldn't use a 2, 4, or a 6. And that's going to be because the increment between them, the .014, is far too small of an increment to use safely. A key cut in the 6th chamber, the 5th chamber, to a 1, and then a key cut to in the 6th chamber to a number 2. That's going to be a problematic. So it's a 2-step progression that you would use when you're building the key bitting array. Notes that are important will also be here. Let's see if we can get the camera to focus one more time for us. Okay, use code card, etc., etc. Just important, any sort of information that you need to know is going to come right in this area. Note, some Canadian locks require cuts that are 0.005 deeper. Use the small marks when you're cutting those. That small mark, the big mark 1, the small mark, the difference between these is 0.005, etc. So lots of information on the HPC code cards, and that's the C14. We don't sell them very often, but of course when you're cutting a key, it's completely crucial to have all of the data. And while this gives you your needle marks for your depth and your spacing, it gives you all this other information. So using this tool alone, you will be able to cut that key using a manual key duplicator. Not that you would want to do that, but you could. You could, I suppose. You could cut it with a file if you have a caliper, but will give you the information necessary. You can also, backwards engineer what a key is cut to. If you know the depth and spacing data, you can measure it, physically measure a key, and then understand the system that you're working in, I suppose. Finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the HPC products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the HPC C14 code card for the Corbin Pre-System 70 Z class, 59 series, 60 and 70 and L series, or any other Corbin HPC product, please feel free to reach out to us. Thank you.